Hello friends, in today's session we are going to see some more remaining topics regarding your exploring java.lang package. Okay, so we will start with memory management. Uh, we have already seen the runtime class and we will now see the most common uses of runtime class, memory management and executing additional processes. First is memory management. Although Java provides automatic garbage collection, sometimes you will want to know how large the object heap is and how much of it is left. Okay, so you can predict it. You have to know it previously. You can use this information to check your code for efficiency or to approximate how many more objects can be instantiated. Okay, if you are already aware of how much memory is still remaining, you can decide or you can take a decision of how many objects you can instantiate. To obtain these values, use the total memory and free memory methods. Okay, so now in first part we have seen Java's garbage collectors periodically recycle unused objects. But sometimes you will want to collect discarded objects prior to the collector's next appointed routes. Okay, so every time it is not necessary that you will be dependent on the automatic process. Sometimes you will want to know everything previously, and everything you may want to collect discarded objects prior to the collector's next appointed round. Then you can run the garbage collector on demand by calling the GC method. This is the GC method we have seen. This is the garbage collection method. You can run manually. A good thing to try is to call GC and then call free memory to get the baseline memory usage. Next, execute your code and call free memory again to see how much memory is allocated. Okay, so by using these two methods, GC method and free memory method, you can see how much memory it is allocated. Then we will see the example of this. Runtime R is equal to runtime.getRuntime. It will give you the current runtime option, long memory 1, memory 2, then some integers, new integer of 1000 quantity, then total memory is R dot total memory. It will give you total memory in long. R dot free memory will be stored in memory 1, initial free memory, then garbage collection will be it is run not non-automatically, that is manually. Then again R dot free memory after garbage collection you can display. Then from 0 to 1000, some integers of I is equal to new integer, allocate integers and create the object. Then memory 2 is equal to R dot free memory after allocation. Okay, so how much is remaining after you are creating the integer values or allocating integers, and again memory used by allocation, memory 1 minus memory 2. So what is memory 1? In this case, free memory after garbage collection. Okay, and what is memory 2? In this case, free memory after allocation. So free memory after garbage collection minus free memory after allocation. We will be displaying this here in this message, memory used by allocation. Okay, then discard integers. Some ints is equal to some ints of I is equal to none, and then again we call the garbage collection. Then memory 2 is equal to free memory. Free memory after collecting discarded integers, memory 2. So what you are doing in this case, in this program, you are first of all viewing the total memory, then first of all initial free memory. Okay, then garbage collection, calling, then again free memory after garbage collection, then allocate integers, and after that again free memory you are calling. So you are actually free memory used by allocation, actual allocation will be displayed over here. Again you are deallocating, you are requesting null value at some ends of I for 1000 quantities, and again you are calling the garbage collection. After that what you are doing, you are again calling the free memory. Memory 2 is equal to R dot free memory. Free memory after collecting discarded integers is equal to memory 2. Okay, so this is the total play of your total memory, free memory, and garbage collection methods. Sorry. Sample output of this program. We can see total memory is 1048568, initial free memory 751392, all else is occupied. Free memory after garbage collection is 841424. Okay, some more space is garbage collected over here, so some space is acquired. Free memory after allocation 824000. Okay, then memory used by allocation 17424, and free memory after collecting discarded integers, again it is 842640. This is just a sample output. Your actual output, depending upon your PC, your free memory will be different. Okay. Then executing other programs. In safe environments, you can use Java to execute other heavyweight processes, that is programs on your multitasking operating system. What in safer environments. Okay, in that environments you can use Java to execute other heavyweight processes. Several forms of execute method allow you to name the program you want to run as well as its input parameters. Okay, so exec method or execute methods have different formats or different syntaxes that will allow you to name the program you want to run as well as its parameters. Execute method runs process object which can then be used to control how your Java program interacts with this new running process. Okay. Execute what, return what? Process object. So we'll control how your Java program interacting with this new running process. Because Java can run on variety of different platforms and under a variety of operating systems, execute is inherently environment dependent. Okay. The following example we will see, it uses execute to launch Notepad Windows sample text editor. This sample must be run under Windows operating system. Runtime R is equal to get runtime process P. Process P is equal to null. Try P is equal to R dot execute. You can look at this layout, that this line P is equal to R dot execute Notepad. Okay, this slide is same as when you are running, for example, you are going to your tab to start the programs. Okay, after that you are clicking on the search button and you are writing there run, RUN run. Okay, so for run you can then specify which type of program you can run. You can print there, type there like Eclipse or your Visual Studio or your Chrome or your Mozilla or your Notepad. Same way, it is just a same thing written in programmatical format. What program you are going to execute over here? It is a Notepad. Okay. Then error executing Notepad if it is not found. There are several alternative forms of execution, but the one shown in the example is the most common. You are specifying name and the input. The process object written by exec can be manipulated by process methods after the new program starts running. Then you can kill the subprocess with the destroy method. The wait for method causes your program to wait until subprocess finishes. The exit value method returns the value written by the subprocess when it is finished. This is typically 0 if no problems occur. Okay. If you are having subprocesses, you can kill them using destroy method. The wait for method wait until the subprocess is finishing. Then exit value returns the value written by subprocess when it is finished. Okay, so if subprocess is finished successfully, it will return 0. Otherwise, it will give you non-zero value. The preceding example modified to wait for the running process to exit. R dot runtime dot get runtime process P is equal to null. R dot execute Notepad and P dot wait for. Okay, then after done, it will give you P dot exit value. If it is successfully closed, it will give you Notepad return 0. Okay. While subprocess is running, you can try to and read from its standard input and output. The get output stream and get input stream methods return the handles to standard input and output of the subprocess. Input output is examined in detail in upcoming sessions. Okay. Process builder. It provides another way to start and manage processes. All processes are represented by process class and processes can be started by runtime.execute. Okay, so how to start and manage processes using process builder, and processes are represented by process class and starting you can use runtime.execute. Process builder offers more control over the processes. For example, you can set the current working directory and change environmental parameters using the process builder class. Process builder constructors are process builder list of string arguments, process builder string tree where arguments three times dot arguments. First is Rs is a list of arguments that specify the name of program to be executed along with any required command line arguments. The first constructor, the arguments are passed in the list. In the second, they are specified through the var parameters. Now we will see some examples. Okay. Returns a reference to a list string command. Returns a reference to a list that contains the name of the program and its arguments changes to this list affect the invoking process. Process builder command this string argument sets the name of the program and its arguments to those specified by arguments changes to this list affect the invoking process returns a reference to the invoking object. Then process builder command string argument sets the name of the program and its arguments to those specified by arguments. Returns a reference to the invoking object. File directory returns the current working directory of the invoking object. This value will be null if the directory is the same as that of program, Java program that started the process. Okay. Then process builder directory, file directory sets the current working directory of the invoking object, returns a reference to the invoking object. Okay. Then map string environment returns the environmental variables associated with the invoking object as a key value pairs. Then Boolean redirect error stream returns true if the standard error stream has been redirected to the standard output stream. Returns false if the streams are separate. Process start throws IO exception begins the process specified by invoking object. In other words, it runs the specified program. And if it's not successful, it will give you input output exception. System. The system class holds the collection of static methods and variables. So what is system? It's a collection of static method and static variable, and it's a combination of them. The standard input, output, error, output of the Java runtime are stored in the input, output, and error variables. The method defined by system are shown here. Many of the methods throw a security exception. Okay, because system is a main class, so it will throw a security exception if an operation is not permitted by the security manager. So some common uses of system. What are the uses of system? To create a process using process builder, simply create an instance of a process builder specifying the name of the program and any needed argument. To begin execution of the program, call start on that instance. Here is an example that executes the Windows text editor notepad. Notice that it specifies the name of the file to edit as an argument. Now we will see the example process builder process. New process builder notepad.exe test file process.start. Error executing notepad. Okay. Then methods defined by system. Now we will see the system methods. Array copy, object source, integer source start, object target, integer target start, integer size. Copies an array. The array to be copied is passed in source, and the index at which point the copy will begin is source start. Then array that will receive the copy is stored in target, and the index at which the copy will begin will be target start. Size is the number of elements that are copied. Then static string clear property. string which deletes the environmental variable specified by which the previous value associated with which is written. You can see these are the very confidential examples or methods. Okay, clear property. Property variable is only modified by the administrator of the computer, as you have already aware about. Okay, system property variables, those are stored for your laptop or for your desktop or your computer, are solely dependent on or solely with the responsibility of administrator. Okay, no other than the owner of the PC or computer can change the property values, but here they are specified uh, as your method, system methods. Okay, so these methods are directly related to your system variables or system method. And if your system is not allowing to do this all, it will give you error and it will throw the security exception. Then static console returns the console associated with the Java virtual machine. Null is written if the JVM currently has no console. Then static long current time millisecond returns the current time in terms of milliseconds in midnight January 1, 1970. Okay, then static void exit integer exit code halts the execution and returns the value of exit code to the parent process, usually the operating system. By convention, 0 indicates normal termination, all other values indicate some form of error. Then static void garbage collection initiates garbage collection. Then static map string get environmental variable returns a map that contains the current environmental variables and their values. Static string get environment string which returns the value associated with the environmental variable passed in which. Okay. Then static properties get properties returns the properties associated with the Java runtime system. The properties class is described in upcoming chapter. The static string get property integer string which returns the property associated with which a null object is written if the desired property is not found. The static string get property string which string default returns the properties associated with which if the desired property is not found default is written. Then static security manager get security manager returns the current security manager or null object if no security manager is installed. Then static integer identity hash code object returns the identity hash code for object. Okay. Static channel inherited channel returns the channel inherited by the Java virtual machine. Returns null if no channel is inherited. Then static void load string library file name loads the dynamic library whose file is specified by library file name, which must specify its complete path. Then static void load library string library name loads the dynamic library whose name is associated with library name. Then static string map library name string library returns a platform specific name for the library name library. Then static long nano times obtains the most precise timer in the system and returns its value in terms of nanoseconds since some arbitrary starting point. The accuracy of the timer is unknowable. The static void run finalization initiates call to the finalize methods of unused but not yet recycled objects. The static void set error print stream sets the standard error stream to eStream. Then static void set in input stream iStream sets the standard input stream to iStream. Static void set error print stream eStream sets the standard error stream to eStream. Static void set in input stream iStream sets the standard input stream to iStream. Static void set out print stream oStream sets the standard output stream to oStream. Static void set properties system properties sets the current system properties as specified by system properties. Then static string set property string with string v assigns the value v to the property name which. Static void set security manager sets the security manager to that specified by security man. Okay, using current time millisecond to time program execution. One use of system class that you might find particularly interesting is to use the current time millisecond method to time how long various parts of your program take to execute. The current time millisecond returns the current time in terms of milliseconds since midnight January 1, 1970. Okay, from 1971 midnight 0000 it will give the millisecond. Time will be written in terms of millisecond from January 1, 1970. To time the section of your program, store this value just before beginning the section in question. Immediately upon completion, call current time millisecond again. The elapsed time will be the ending time minus the starting time. Okay, so first of all, what you will do, you will take the current time in millisecond from this from this date January 1, 1970. You can store this value in millisecond, and then if you want to find out how much time your program is taken to execute, you will again call this current time millisecond again. Okay, so now you will subtract this value, or sorry, this value from this value, and then you can get the total time elapsed. Okay, now elapsed time start end timing for loop from 0 to 10 lakhs. Then start system dot current time in millisecond get starting time. For I is equal to 0, I less than 10 lakhs. End is equal to system dot current time in millisecond get ending time. Okay, so this is a empty for loop. There is nothing written over here, and after this loop is completed, you are getting system dot current time in millisecond, and your elapsed time will be end time minus start time. Okay, so after completion, what is the current time minus when we started? End minus start will give me elapsed time. If it is a sample run, remember that your result probably will be different. Timing elapsed time is equal to 10. If your system has a timer that offers nanosecond precision, then you could rewrite a preceding program to use nano time. If your system is supporting rather than current time millisecond, for example, here is the key portion of the program rewritten to use nano time. System.nanotime gets starting time and system.nanotime gets ending time other than your current time in millisecond. Okay, so nano time is very exact time if your system is supporting it. Then using array copy. The array copy method can be used to copy quickly an array of any type from one place to another. This is much faster than the equivalent to written out longhand in Java. So if you want to directly copy an array of any type from one place to another, this is a very much fastest way. Here is an example. First A is copied to B. Next all of A's elements are shifted down one by one and B is shifted up one by one. Okay. So now array A, array B, byte B. Byte array A, byte array B. A is equal to new string A. B is equal to new string B. Then system array copy A0, B0. Okay. So this is array. So now what we are doing for A length from 0 you are starting to copy from A to B 65, 66 up to 74, and then first is you can copy the same source and destination in either direction. Here A, B, C, D, E, F, G, H, I, J, and B is M, 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 M. Okay, why M? Because 77 is the ASCII value of M. Okay, then what we are doing? We are copying the value A, B, C, D, E, F, G, H, I, J from A to B. Then again, what we are doing? A, B, C, D, E, F, G, H, I, J. Okay, so what we are doing in this case, here A0, A1. You are copying the same array to the same array, and then your display output is from A 2 times and J is omitted over here, and in B you are having A is not there, B, C, D, E, F, G, H, I, J, J. Okay, so this way you are using the array copy method. The best example, best way is to practice this program so that you will understand it better. Okay. Environmental properties. So environmental properties are available: file separator, Java class path, Java class version, Java compiler, Java ext directories, Java home, Java IO, temp directory, Java library path, Java specification name, Java specification vendor, Java specification version, Java vendor URL, Java version, Java virtual machine name, Java virtual machine specification name, Java Virtual Machine Specification Vendor, Java Virtual Machine Specification Version, Java Virtual Machine Vendor, Java Virtual Machine Vendor, Line Separator, OS, ARC, OS Name, OS Version, Path Separator, User Directory, User Home, and Username. These are the environment properties available. Okay. You can obtain the values of various environment variable using system.getProperty method. For example, we will see the example program that displays the path to the current user directory. So how to get it? System.getProperty method, as we have already discussed, and user.directory will give you the path to the current user directory. So how to display it? System.out.println, system.getProperty, and here property name user.directory. Okay, this is the property name. You can use any property name to display the value. Then object. As mentioned in part 1, object is a superclass of all other classes. Object defines the method shown in table 16.14, which are available to every object. So methods of object are clone. Throws, clone not supported exception, creates a new object that is same as the invoking object. Boolean equals object, returns to its invoking object is same as the object. Void finalize, default finalize method, this is usually overridden by subclasses. It's throwable. And then final class, get class. Obtains a class object that describes the invoking object. Then integer hash code. Returns the hash code associated with the invoking object. Final void notify, resumes the execution of the thread waiting on the invoking object. Then final void notify all, resumes the execution of all threads waiting on the invoking object. Then string to string returns a string that describes the object. Final void wait throws interrupted exception waits on another thread of execution. And final void wait long milliseconds throws interrupted exception waits to the specified number of milliseconds on another thread of execution. Then final void wait long millisecond integer nanosecond throws interrupted exception waits of the specified number of milliseconds plus nanosecond on another thread of execution. Okay, now we will see using clone and the clonable interface. Most of the methods of object are discussed elsewhere in this session. However, one deserves special attention, that is clone. It is a copy of the object. The clone method generates a duplicate of copy of the object on which it is called. Only classes that implement clonable interface can be cloned. Very important line, you can note it down. Only classes that implement the clonable interface can be cloned, or those classes objects can be copied or whose copy can be created. The clonable interface defines no members. It is used to indicate that class allows a bitwise copy of an object to be made. If you try to call clone and a class that does not implement clonable, clone not supported exception will be thrown. And when clone is made, the constructor for the object being cloned is not called. Clone is simply an exact copy of the original. Okay, the constructor is not called like any other object creation. It is just a copy of the original object. Clone is potentially dangerous action because it can cause unintended side effects. For example, if the object being cloned contains a reference variable called object reference, and then when the clone is made, object reference in a clone will refer to the same object as does object reference in the original. Okay, so it is very dangerous. If the clone makes a change in the contents of the object referred to by object reference, then it will be changed for the original object too. If an object opens input-output stream and is then cloned, two objects will be capable of operating on the same stream. And if that input stream or output stream is confidential, it is very much dangerous thing. Further, if one of these objects closes the stream, other object might still attempt to write it to it, causing an error. You will need to override the clone method defined by object to handle this type of problems. Okay, so you can override the clone method. So to avoid when one is writing to it, other cannot read it, or if one is reading it, other cannot write to it. You can define such an operation by overriding the clone method so that this type of errors can be omitted. Okay, because cloning can cause the problem, clone is declared as the protected inside object. This means that it must either be called from within a method defined by the class that implements the clonable interface, or it must be explicitly overridden by the class so that it is public. Okay, so there are two ways. It must be either be called from within a method defined by the class that implements the clonable interface. Whichever class who is implementing the clonable interface, inside that class's methods, you can clone the object, or it must be explicitly overridden by that class so that it is public. Now we will see both the approaches. Okay, following program implements the clonable and defines the method clone test, which calls the clone in object, demonstrate the clone method. Okay, so integer a double b are two variables. Test clone, clone test method is created. Return test clone super dot clone. Okay, so we are calling here clone method, and cloning not allowed, clone not supported, exception, return this. Okay, then clone demo. In main method test clone x1 is equal to new test clone. This is the test clone class, clone test. This is the test clone class, and this is the clone test method, which returns the clone object of the class clone test clone. Okay, test clone x2, x1 dot a is equal to 10, and x1 dot b 20.98. Okay, so here is 10, here is 20.98. And x2 is equal to x1 dot clone text. So x1 dot clone text will return the same object here, super dot clone. X1 object's clone text will return the same object and it will be stored in x2. So x1 and x2 are now the same objects. So x2 dot a will be 10 as well, and x2 dot b will be 20.98. Okay. The method clone test calls clone in object and returns the result. Notice that the object returned by clone must be cast to its appropriate type. Okay, so that we have written this test clone. Because clone is allowed for all types of object. What is the type of object that we are using? It is a class test clone. So for that purpose, we have to cast it. Then the object returned by clone must be cast to its appropriate type. The following example overrides clone so that it can be called from code outside of its class. That is, it is public. Okay. To do this, its access specifier must be public. Test clone, clonable. Clone is now overridden and it is public object clone. And we are overriding it. Call cloning object return super dot clone. Clone not supported exception. What we are doing, new test clone x dot a 10 20.98. Here we can call the clone directly because it is a public method now. It's a public method and it is a overridden method, and it is returning super dot clone. So in main method we are calling it directly x1 dot clone, and it is casted to its appropriate type test clone and stored into x2. And both the x2 and x1 are identical now. So x2's a will be 10 as well, x2's b will be 20.98. Okay. The side effects caused by cloning are sometimes difficult to see at first. It is easy to think that a class is safe for cloning when it actually not. You should not implement clonable for any class without a good reason. Okay. Why? Because your confidential data can be accessed by the malperson. For that purpose, do not implement clonable for any class unless you are having a strong reason to do this. Okay. So this way we have seen some interesting topics inside your exploring java.lang package. In the next session, we will see some more examples, some more topics, interesting topics. So meet you in the next session with the new topics. So thank you so much.